For decades, astronomers have struggled to measure the rotation period of the Sunday and Sunday-like stars. The reason? The brightness variations on these stars, which scientists use to track rotation, are highly irregular. This makes it difficult to get precise measurements, especially in visible light. Now, a new study has found a way to solve this problem by looking at the sun in ultraviolet (UV) light. The sun's rotation is an important characteristic that influences everything from stellar activity cycles to planetary conditions. Understanding how it rotates helps scientists determine the age of other stars and distinguish between planetary signals and stellar noise when searching for exoplanets. However, past studies using space telescopes like Kepler and TESS struggled to measure the sun's rotation correctly because visible light curves are too messy. Stars like the sun are covered with sunspots and faculae, regions of strong magnetic activity that cause the star's brightness to fluctuate. When astronomers try to track these brightness variations to measure rotation, they run into a problem. Sunspots don't last long enough. Since sunspots appear and disappear faster than the sun completes a full rotation, about 27 days, they create an inconsistent pattern in the light curve. This makes it hard to detect the actual rotation period using traditional methods. To make things worse, sunspots and faculae counteract each other. Sunspots make the sun darker, while faculae, brighter regions near sunspots, increase brightness. This mix of dark and bright features makes the rotation signal even harder to detect. To solve this mystery, a team of researchers, led by Valery Vasilev, investigated how well the sun's rotation can be detected at different wavelengths. They used solar irradiance data spanning multiple decades, analyzing light from UV to infrared. Their findings revealed a game-changing insight. The sun's rotation is much easier to detect in UV light than in visible light. Here's why. Faculae last much longer than sunspots. Since UV light mainly comes from faculae, it creates a much more stable pattern over time. This makes the rotation signal clearer and more detectable. UV observations show a strong and consistent 27-day rotation signal. The probability of correctly measuring the sun's rotation in UV light is 80%, compared to just 20% in visible light. This means that future space telescopes designed to observe UV light from other stars will have a much better chance of accurately determining their rotation periods. This discovery has huge implications for the study of stars and exoplanets. Since astronomers rely on rotation measurements to determine a star's age and magnetic activity, this new UV approach could radically improve stellar observations. It also helps in the search for Earth-like planets, where distinguishing between signals from a planet and a star is critical. Moving forward, space telescopes equipped with UV sensors, like the upcoming Ultraviolet Explorer and LUVOIR mission, will play a key role in unlocking new secrets about our sun and the stars beyond. This study confirms that sometimes, the best way to study the universe is by looking at it in a different light, literally. Thanks for watching. If you enjoyed the video, give us a like, comment, and subscribe. And don't forget to click the bell icon to stay updated on the latest space discoveries.